everyone. Welcome to Larson in the Lab. I'm back again. This time I don't have goggles or apron on because I'm not working with any hazardous materials. I'm just working with pennies today. We're going to do a lab called the isotopes of Pennium. And I'm going to read a little bit off of this sheet just to make sure that you understand what we're going to be doing. And then I'll help you get started with the lab. So if you are a hybrid student, you're actually going to be able to do this lab on Thursday or Friday, whichever day you're in class. But if you are an online student, I'm going to be supplying you with the data and you will complete the rest of the questions on the lab. So here's a little introduction. All pennies in circulation seem to be identical in size, thickness, and composition. However, pennies of different years have different masses. In this lab, we're going to use pennies with different masses to represent the isotopes of the imaginary element pennium. We will find a weighted average of the mass of a penny based on their abundance in circulation. Our procedure. First, count 20 pennies from a cup. Guys, I had a beaker full of pennies and I already actually counted out 20 of them. You can see them here. I've separated them into two piles. One pile here has the pre-1982 pennies. These are all pennies with a date that was prior to 1982. This pile here is all of the post-1982 pennies. What I'm going to do next is count the number of pre-1982 pennies that I had and find their mass using the balance. I'll record my data in the data table. So here, guys, I have 5 pennies from pre-1982, and what I've done is I've prepared my electronic balance, and it's already zeroed, meaning that the mass currently on that balance is 0. Now, I am not going to put one penny at a time to figure out the mass. I'm going to put all 5 of these at one time on the balance. The reason is that little pennies have different amounts of wear and tear, so a slight difference between one penny to the next won't matter when we're taking the average mass of these pennies from before 1982. So 5 pennies, I'm putting it on the balance, and their mass is 15.46 grams. So what I'm going to do is I'm going to record that in my data table. And for those of you doing the lab online, you will have this information available in the Google Forms sheet if you're in my class. So the number of pennies is 5. And the total mass was 15.46 grams. I'm going to use that later to figure out the mass of just one penny, and then I can use other information to find out the abundance of these certain pennies pre-1982 and post-1982. Next up, I'm making sure my balance is zeroed again, and I'm going to find the mass of these other pennies that are from post-1982. There happen to be 15 of these post-1982 pennies here, and I'm putting them on the balance now. My total mass of the post-1982 pennies is 37.59 grams. So what I'm going to do here is I'm going to put that there were 15 of these pennies and they had a mass of 37.60 actually grams. Next, what we're going to do is find the mass of one penny by dividing the total mass by the number of pennies. Again, note, I did not put just one penny on the balance. So what you will do is you will take the mass, the total mass of the pennies, and divide it by the number of pennies. You'll do that for the pre-1982 pennies, and you'll find the answer. And then for the post-1982 pennies, you will do the same. Take the mass and divide it by the number of pennies to find the mass of one penny. Next, what we're going to do is find the abundance of each type of penny by dividing the number of pre-1982 pennies by the total number of pennies and multiplying by 100, and repeating that for the post-1982 pennies. You can record that in your data table. So if we're looking at this, we've got 20 total pennies, and you'll be able to calculate the abundance of each type of pennies by doing for pre-1982, 5 divided by 20 times 100, and there will be a space for you to put your answer. And for post-1982 pennies, 15 divided by 20 times 100, you can put your answer in the space provided for you. The next thing you're going to do is to calculate the average atomic mass of pennium. And you may show your work on scratch paper, though I am going to require that you just let me know what your average atomic mass of pennium was. To figure that out, you'll multiply the average mass of just one pre-1982 penny by the percent abundance of the pre-1982 pennies. Next, you'll repeat that step. You'll multiply the average mass of one post-1982 penny times the percent abundance of the post-1982 pennies. Then you add your results together and divide your answer by 100. You've got to follow order of operations here, or else you might get an incorrect answer. If you need help, your teacher will be happy to help you out. The last question for this lab is a conclusion question, and we'd like you to write in complete sentences. What do the 20 pennies in this investigation represent? Thanks so much for listening.